Hi, I'm Dave Hunter, an RF system engineer here at Vanteon. Today we're going to talk about transmitters. So I have here is block diagram of a super heterodyne transmitter, and for simplicity we're just going to talk about audio or analog modulation. So going through the block diagram, we have our analog input, which is speech, microphone, modulator, which could be either an AM modulator, FM modulator, in this example. That puts out an RF signal or an audio signal, depending on how. And if it's AM, it'll be audio. If it's FM, it'll be RF. And then that gets mixed up. So we have an LO again, and the mixer. And then of course, you get two outputs from the mixer of the frequencies. So this is acting as your IF, and this is acting as your RF frequency. So we're mixing to the RF that we're talking about. So the bandpass filter takes out the frequency we don't want, keeps the frequency we do. And in a usual, you have what's called a driver, which has a certain amount of gain, and they're typically around 20 dB is the usual driver. And then you have a power amplifier. And these are usually lower gain because they're higher power. So that's where the reason for the driver is sometimes you don't have enough signal power directly from your driver to your power amplifier. And then your power amplifier has harmonics on its output, and so the low pass filter is to get rid of those. And those are usually required by FCC or other organizations for a proper signal. For some low power applications, things like a sensor or other low power Internet of Things kind of device, sometimes you can get by with just the driver and have that as your final amplifier. You put your antenna there. So it depends on what power you need. And so that's the basics of transmitters. Thank you for watching.